Hello. I wanted to introduce the graphical user interface we're distributing with the L-Range modeling family now. This is a way to get a rapid look at modeling results. It's a way to visualize results through space and time, to get a sense of how pixels in different parts of a map may be responding. It's not really for in-depth analyses. There are other ways to do that work. We'll address some of those in another video. This is to get a rapid view of how the model is responding. There were two main versions of the graphical user interface distributed. One was with the original release of G-Range, and that was a decade ago. It used a programming language that's no longer supported called Visual Basic 6. And so it was similar in many ways to what I'll talk about here, but there were also aspects that weren't used very much. But really, it doesn't work very well on modern operating systems. It only worked on Windows operating systems and potentially could work for people who are using an older operating system. But if you try it and it doesn't work, if you've got one of those original G-Range distributions or the like, and it doesn't work, then please do use the new version and it should be much better behaved. The version we're distributing now is in Python. And again, it's a very simple tool. Python, of course, is cross-platform, meaning that the code should work in a Windows platform, in a Unix or Linux distribution, in a Mac platform. It should work no matter what type of computer you may be using. Now, there are some requirements for the tool to be used, and they're really quite straightforward. It might sound a little scary, but it's an easy thing. They include 3 libraries that are not incorporated into Python 3. So you do, of course, need Python 3 installed on your computer. It's very likely that you already have that installed. It's used by many tools now, but still you could install that if you didn't. And so search for Python 3, whatever version follows, and install that, and you should be good there. That includes a tool called tkinter, which is used for the graphical user interface. So that's already addressed. And 3 other tools need to be installed as well. They're shown here, and installing them is as simple as you see here. If you have the Python 3 installed, you will have unknowingly perhaps installed a tool called pip, which supports the installation of libraries. So if you say pip install and then matplotlib, a very common library used in Python programming, then you'll install that library. It should happen pretty quickly. And you can do the same for NumPy, which is a library that supports storing of large arrays of numbers in Python very efficiently. And then another library that's called Pillow. And so if you'll install that as well. So it's as simple as saying pip install NumPy, pip install Pillow. I would do the same and show you, but I already have them installed on my machine, so it wouldn't carry through. Now, 2 other things. First off, of course, you need the Python file in the folder of interest to you. So download that file and put it in a place where you'd like to save it, like L-Range GUI or whatever you'd like to call the file. Then you need to have what's called an ini, or a configuration. It's an initialization file or a configuration file. People who've been around a long time know them as ini files. They are configuring a given program. This is used in many places in the L-Range family of models to learn that first highest level step. If this graphical user interface runs, where should it find the model of interest? That's it. It needs to know that. And so This ini file contains one line, and it's a pointer to the main application of interest to you. So in my case, I've got the AFRange application on my F drive, for example, and it's under AFRange. So you'd see the line quote F underscore AFRange / AFRange close quote, and that's pointing the GUI to the appropriate file. This is, or set of files. This is addressed on the download page as well. So you can go there and see the same thing repeated. Once the libraries are installed and the ini file is in place, and of course a Python file is in place, you should be able to click on the Python file and it will bring up the utility. Again, quite simple, it's quite straightforward. Here's an example for, again, AFRange. So you can see Africa. We have what? 4 panels plus some sliders. I could deal with the sliders initially. You can see that they are simply year and month. And I've got a little zoom tool, magnifying tool enabled. So here you see that they are year and month. And so you can slide those back and forth to change the year and month being visualized. There's a graphing panel down below. As we click on cells in the map, it will graph the results through time down below. There, of course, is the mapping window. And then there's a long list of the surfaces that are being produced by LRange, AFRange, GRange, whatever the tool is you're using. Now, your list may differ from what you see here because you can turn on and off individual elements in the output list as discussed in a parameter file video. And so by turning on and off individual entries, you can disable many of these surfaces if you wish to save disk space or speed it up or what have you. But here, and in fact, there are probably some that are disabled, so your list may be a little longer. But here you see an example of outputs. This is the X location, perhaps not very exciting. It's all the same. It's actually model input rather than output. The same is true, for example, for Y location. Rangeland type is the landscape units that are used in modeling the work. Again, precipitation for the first month of the simulation is model input rather than output. And you can see all the rest of the surfaces that are included in output. Now, there are two types of output files. One is a file that includes just a single layer. And so you may guess, for example, that bare cover includes just a single layer. Here's bare cover for Africa, at least in this draft model. It's not finalized yet, but you can see high bare cover for the deserts of Africa. Now, bare cover, percent bare cover is a single layer, and there's information at the bottom of the GUI that expands on its nature and gives a units report. So here you see bare cover stored rather than continually something 3 facets. It says proportion. So this is proportion bare cover or percent bare cover. And so we see that by its nature is a single layer. Bare cover is just one number for every pixel. And so there's one surface produced every month. And so again, I can change the month that's portrayed. I can change the year that's portrayed, slight differences through time here as things shift. In contrast, there are other surfaces that have more than one layer. So if I click on facet cover, for example, nothing changes in the map. It clears it out. But what it's doing is waiting for me to indicate more information because facet cover is 3 layers. It includes herbs, shrubs, and trees. And so I have to click on whatever I wish to be portrayed, whether I want the herb facet, shrub facet, or tree facet. And again, we've got herbs, shrubs, trees in this draft African model. And down below, the proportion occupied by each cell, proportion with 3 facets. And so that's the graphical user interface. You can click on various elements. And again, the magnifier shows if I click, it reads through and maps out changes in this case forest cover because I have facet 3 selected. If I go to bare ground and click on, well, the Sahara, for example, should have 100% bare ground. And so in the graph below, you see that it's 1.0 through time. And that's going to vary as the model progresses. So if I click on that cell, you see that the cell is shown in red. And then down below is another graph that's showing the changes in the proportion of bare ground for that cell through time. And so again, a person can get a sense of the different responses through time and the spatial patterning of responses as well. Again, there's another set of data input down below for silt, sand, and clay. And again, if I select sand, it's got 4 layers of information. So I have to select a layer before the information will be updated and displayed. So here we have topsoil, and then the upper topsoil, or lower perhaps, and then the subsoil, etc. And then many more outputs, such as monthly net primary production and changes in that production both across months as seasons pass and across years.